All right, so this is an example of an electric motor, and you'll notice that we have a switch, power supply. Thanks, Mr. Laurent, nice hand. And then this motor has two permanent magnets. One has a south on one side, thank you, and then on the other side there's a north. And the electromagnet is in the middle, and you'll notice that at the top of the electromagnet there's a copper ring, and the copper ring has two slices in it, and that's really important because when the current comes in, the current passes through the coil, and then there's a magnetic field that's created on the electromagnet. And so when it gets to this position, the north of the electromagnet is right here, the south of the permanent magnet is right there, and so they attract. And once it gets to this position, if there was no break in that ring, it would just stay there. But because the ring is there, the current gets cut off, and then it goes through, and once it gets far enough through, the current actually goes through the coil in the opposite direction. So now you have a south for the permanent magnet and a south for the electromagnet, and then they repel each other, so they get pushed like that until they get to this position again. The current switches again, so it's constantly having its current switch, which means the magnetic field is constantly switching. So here's what it looks like when it's running. And a lot of times you have to give it a little push. And then if you increase the current, that increases the voltage, which makes the motor spin faster. Nice.